Toyota hybrid system, Honda hybrid system, Prius versus Accord hybrid, e-CVT versus eHEV. Everyone throws those names around like they're the same thing. They're both Japanese, both hybrids, both reliable, just pick one. That's not how an engineer looks at it. Under the skin, Toyota and Honda made two very different bets about how a hybrid should work. Toyota uses a power split system with planetary gears, where the engine and motors are always mechanically tied together. Honda uses a two-motor, mostly series hybrid setup with direct drive at speed, essentially an EV with an engine bolted on. Those choices change how they drive, where the stress lives, how they age at 150,000 to 300,000 miles, and which one you'd rather own long-term. I'm GearHead. I don't care what marketing calls them. I care about torque paths, thermal loads, battery cycling, and whether you're going to regret buying one of these used in 10 years. If that's the level you want to understand Toyota versus Honda hybrids at, make sure you're subscribed. This is exactly the kind of deep dive people wish they'd seen before signing a loan. Let's break down each system properly, then stack them against each other. Start with Toyota, hybrid synergy drive, and the so-called e-CVT. You'll see this in the Prius, Corolla, and Corolla Cross hybrid, Camry hybrid, RAV4 and Highlander hybrid, Lexus RX, ES, NX, and UX hybrids, and a bunch more. The core pieces are an Atkinson-cycle gasoline engine, MG1, which is a motor and generator, MG2, the main drive motor and generator, a planetary gear set acting as the power split device, and a reduction gear plus differential. Here is a very simplified power path. The engine, MG1 and MG2 are all mechanically linked via the planetary gear set. MG1 can start the engine or act as a generator to charge the battery or feed MG2. MG2 can drive the wheels or regenerate energy when you brake. By controlling how fast MG1 spins, forward or backward, the engine control unit decides how much of the engine's power goes mechanically to the wheels, and how much goes electrically through MG1 to the battery or MG2 and then to the wheels. Important note, there is no belt, no cone pulleys, and no traditional CVT mechanism. It feels like a CVT from the driver's seat, but mechanically it's fixed gears and electric machines. The drive modes blend like this. At low speed and light load, MG2 can move the car with the engine off in EV mode, battery permitting. In normal driving, the engine runs in an efficient RPM band, MG2 assists, and MG1 controls the power split. You get that engine hum stays steady while speed changes feel. During braking, MG2 acts as a generator, sending energy back to the battery. Strengths of Toyota's design include having few moving parts in the transaxle, just one planetary set, two motors, and some reduction gears. There are no clutches constantly engaging gear sets and no torque converter to lock or unlock. It is very smooth and very tolerant of abuse if cooled and lubricated properly. Weak points in the full hybrid system, not just the transaxle, include inverter cooling and electronics, especially in early Prius generations, though many were fixed under recall. Engine-side issues on specific generations, like EGR clogs leading to head gasket failures on the Generation 3 1.8-liter if neglected. Battery aging and hot operation if the battery cooling fan and ducts are never cleaned. And owners stretching oil and coolant intervals way too far. The real-world record speaks for itself. Prius taxis doing 300,000 plus miles on original transaxles, Camry hybrids in Uber duty over 200,000 miles, and Lexus hybrids aging out from rust or suspension wear before the e-CVT ever dies. Toyota's whole vibe is under stress everything, take the efficiency gains and leave big safety margins. Now for Honda, eHEV, the two-motor hybrid system. You'll see this in the Accord hybrid, CR-V hybrid, the latest generation Civic hybrid, the Jazz and Fit hybrid, the HR-V hybrid, and similar models globally. The core pieces are a 2-liter or similar Atkinson-cycle gasoline engine, a generator motor connected to the engine, a drive motor connected to the wheels, a fixed ratio gear path with a clutch that can directly connect the engine to the wheels, a battery pack, and power electronics like inverters and DC to DC converters. The key idea is that Honda's system is series dominant most of the time, with a direct drive mode at higher speeds. There are three main modes. First, EV drive. At low speeds or light loads, if the battery has enough charge, the engine is off. The drive motor powers the wheels from the battery, and it feels like a pure EV. In middle speeds, or when the battery is low, the engine runs, spinning the generator. The generator produces electricity, which flows to the drive motor to move the car and/or to the battery. The wheels are only driven by the electric motor. The engine does not mechanically touch the wheels. In higher speeds or steady cruising, a clutch engages a fixed ratio gear. The engine connects mechanically to the wheels through that gear. The drive motor can still assist or regenerate, but the engine is now a direct prime mover. So in town and in traffic, an Accord hybrid or CR-V hybrid drives like an EV with a generator feeding it. On the highway, it behaves much more like a regular gas car in a single gear with electric assist. Strengths of Honda's design include outstanding low-speed refinement. It feels very EV-like. The engine can be run at its most efficient points as a generator a lot of the time. Direct drive mode avoids constant conversion losses at highway speed, and there is no multi-gear stepped automatic or belt CVT, meaning no constant shifting or slipping. Potential weak spots long-term. The traction motor is the only drive source at low to medium speeds, so it, along with its bearings and electronics, are absolutely critical. The generator motor sees a lot of runtime whenever the engine is on, which is the same story. The direct drive clutch and fixed gear must be robust and well-cooled. If undersized or abused, they can be a future failure point. And the system depends heavily on the health of the inverter and cooling system. Heat is the enemy. The real-world record so far. Modern eHEV is relatively new, arriving from the mid-2010s onward. Early signs are good, with no mass failure headlines, and owners reporting solid reliability to 100,000+ miles. But it has nothing like Toyota's 20-year, 300,000-mile history yet. Honda's whole vibe is to push harder on EV-like drive feel and clever control, with less weight on the idea that this has to do 500,000 kilometers in a taxi in 2005 Cairo.
Number 1. Driving feel. For the Toyota hybrid, it's smooth, but you're more aware of engine involvement. Engine RPM often sits at a drone under acceleration, especially on older generations. Newer models on the TNGA platform are much better tuned for noise, vibration, and harshness, but still, you're driving a hybrid that feels like a very smart gas car with electric help. For the Honda eHEV, low-speed EV feel is very strong, with instant torque, and it is very smooth. The engine is often off or quietly spinning the generator away from what your foot is doing. Highway direct mode feels normal with some electric shove. Many people call it the most refined front-wheel drive hybrid setup to drive right now. Winner on feel, Honda, especially in town. Toyota is very good, but Honda's series-dominant approach is more EV-like. Number 2. Efficiency. Both are very efficient in city and mixed driving. Toyota is insanely good at using every drop of fuel, especially in stop and go. The Prius and Corolla hybrid often beat EPA ratings in real driving. It also does well on the highway because it can still choose engine RPM for efficiency. Honda's eHEV gets excellent real-world miles per gallon too. In many tests, Accord and CR-V hybrids rival or beat Toyota equivalents in mixed driving. On the highway, direct drive avoids double conversion losses. Efficiency depends heavily on the model, tire choice, and driving style. Toyota is a known quantity and very hard to beat on total cycle efficiency. Honda eHEV is competitive and sometimes better in real drivers' hands. Call it a draw on average, with a slight edge either way depending on the specific model and comparison. Number 3. Complexity and stress. Toyota's hybrid Synergy drive is mechanically simple in the transaxle, with few moving parts. The smarter complexity is mostly in software and power electronics. The engine shares the load with the electric side in a very controlled way. It is under-stressed. Toyota often leaves performance on the table for longevity. Honda eHEV has slightly more mode complexity between EV, series, and direct. There is more reliance on the drive motor as the sole traction source in more modes, and an additional clutch interface for direct drive. The engine often runs at steady, efficient points, which is good, but the structural load is all or nothing when in generator mode. From a fewest points of failure perspective, Toyota's system has the simpler mechanical layout. Honda's has more clutches and mode transitions, though still far fewer than a normal automatic. Number 4. Long-term reliability and 300,000-mile odds. This is where they really separate. Toyota has 20-plus years of full hybrid use. Millions of cars have done 200,000-plus miles. Plenty have done 300,000-plus. The transaxles rarely fail if cooling and fluid are halfway respected. Honda eHEV has only about a decade in heavy use. There are very few examples at 250,000 to 300,000 miles yet. So far, there are no systemic disasters, but the sample size and time horizon are smaller. If your question is simply, which hybrid system has the strongest proven chance of going 300,000 miles with routine maintenance, the answer in 2026 is Toyota. It has more scars and more trophies. Does that make Honda eHEV risky? Not exactly. It just means you're buying into a newer architecture whose long-tail behavior we're still watching. Which one should you actually choose? If your priority is EV-like feel, smooth, low-speed driving, a nicely tuned, modern cabin experience, and you're planning on 8 to 12 years of ownership, not 20, the Honda eHEV is a great fit. Accord, CR-V, and Civic hybrids drive really well and are, so far, doing fine on reliability. If your priority is maximum proven longevity, taxi-grade reliability, high-mileage used buying confidence, and truly not worrying about whether the architecture itself will age well, Toyota's hybrid synergy drive with e-CVT is still the safer bet. You choose between Honda, which is a newer, very refined, clever two-motor hybrid that feels closest to an EV, and Toyota, an older, ruthlessly refined power-split hybrid that's been surviving abuse for decades. If this helped you actually see what's going on inside these systems, instead of just Honda versus Toyota, make sure you're subscribed. Next, I'm going to get even more practical. We'll cover what to check differently when you're inspecting a used Toyota hybrid versus a used Honda hybrid, from EGR and coolant stains on a Prius to clutch feel and inverter temps on an Accord hybrid. So you don't just buy the right system, you buy the right car. I'm GearHead. Every hybrid system has a story. And together, we're going to decode the ones you can truly count on past 200,000 miles.